Good morning, everyone. Today we are going to explain about social networking analysis using static graphs. Before we are going to into the technical parts, let's first understand what is social network analysis actually means. In our daily life, we make many connections with the friends, family, classmates, teachers, and people on social media. Social network analysis or SNA is the method used to study these connections. Social network analysis studies connections to reveal influences, information flow, and bridges. Static graph captures a snapshot of the network structures. In social network analysis, each person is a node, each relationship is an edge. For example, if I am connected to you on WhatsApp, that is an edge. If two of your friends talk to each other regularly, that is another edge. When we capture all these connections at one particular moment, we call it as a static graph because it does not show how things change over time. It's like taking a single snapshot of the network. SNA helps to find who is the most influenced person in the group. How does information spread in the group? Who attacks the bridge between different groups? This is the basic idea of social network analysis. Now let's see how we represent network as a static graph. Now let's A static graph mainly has two parts, vertices and edges. Vertices which represents people or entities. Edges which represents connections between them. For example, if A and B are friends, we draw a undirected line between them. If A follows B on Instagram, we draw an arrow from A to B. This becomes an directed edge. To store these connections inside a computer, we commonly use two methods, adjacency matrix and adjacency list. This is adjacency matrix. This is like a list. If two people are connected, we put 1. If they are not connected, we put 0. Adjacency list. This is simpler. Each person keeps a list of who they are connected to. For example, A is connected to B, C, D, and B is connected to A and E. A good real life example is your phone contacts. This list of people saved in your phone is like your adjacency list, a list of your connections. There are different types of static graphs based on how connections works. Undirected graph. Both sides are connected. Example, Facebook friends, if you add someone, both of you become friends automatically. Directed graph. Only one side follows or interacts. Example, Instagram. If you follow a celebrity, they may not follow you back. And then weighted graph. Connections may have weights or values. Example, email connections. If you email a friend 50 times and another friend only 5 times, the first connection is stronger, so the weight is higher. And the fourth one is bipartite graph. Two separate groups of nodes. Example, students and courses. Students belong to one group and courses to another. Edges shows which student has taken which course. And then finally, multigraph. More than one connections between the same two people. Example, between two colleagues, we may have a chat connection, an email connection, a phone connections. All these are separate edges. Now let's understand the key measurements in social network analysis. These measurements help us to understand a personal role in a network. First one is degree centrality. This tells us how many data connections a person has. For example, in a WhatsApp group, the most active person who messages everyone has high degree centrality and betweenness centrality. This finds the person who attacks a bridge between groups. If your two friends circles do not talk to each other directly, but one person connects them, that person has high betweenness. And then closeness centrality. This shows how quickly a person can reach everyone else in the network. A person with a high closeness can spread information fast. Eigenvector centrality. This focuses not only on how many connections you have, but also on how important your connections are. If you are connected to highly influential people, your score increases. And then finally, clustering coefficient. This shows how tightly connected your friends are. If your friends all know each other, clustering is high. If they are from different groups and don't interact, clustering is low. Thank you.
Uh, Good morning, everyone. Now I will explain the structural property of static network. And in static network, understand how nodes are connected is very important. These structural properties help us study the shape, strength, and behavior of a network. The first property is density. Density shows how many connections actually exist compared to how many could exist. If density is high, it means the network is strongly connected and information spreads faster. Next one. The next property is diameter. It is the shortest path between any two nodes in the network. It tells us how the network extends. Another important measure is average path strength. This means the average number of steps needed to go from one node to another. If this value is small, it means nodes are closely connected. Then we have a communities, which are groups of nodes that are made closely linked to each other than to the rest of the network. Communities help us uh, understanding how peoples from groups or clusters. Finally, the significance of this property is that they will help us understand information, follow, and the structure of different communities. Let's move to the next slide. Let's move to the next slide. Algorithm powering social network analysis. Algorithm help us analyze social network by finding connections, influence, and community structure. The first algorithm is breadth first search or BFS. It explores a network larger by larger and helps find the shortest path in unweighted network. Next one is the Dijkstra's algorithm, which finds the shortest path in weight graph and is useful for routing and fast information spreading. Let's move to the next one. The Greven-Newman algorithm detects communities by removing edges that connects different groups. It helps reveal cluster in the network. Let's move to the next one. The page rank algorithm ranks nodes by important using incoming links. It helps if identify users similar to how Google ranks web pages. Let's move to next one. The Lowen algorithm finds communities automatically and work effectively for large networks. Let's move to the next slide. Finally, let's talk about network visualization technique. Visualization means drawing network in a way that help us clearly see the structure, importance of nodes and communities. Some important tools for visualization are Graphy, which allows interactive 2D and 3D visual exploration. NetworkX in Python, used to create custom layouts and analysis. Uh, and in a visualization, we use different layouts such as force direct layout, where nodes move naturally to show clusters. Circular layout, which show equal relationship and around a circle. And next one is color encoding and node size, which highly important nodes or communities. Visualization value adds because it improves pattern recognition, understanding, and communication across different audiences. Finally, let's move to the conclusion. To summarize, structural properties tell us about how networks is organized. Algorithms help us analyze and compute important features, and visualization techniques help us understand the network visually. Thank you.
Mm. Good morning, everyone. Now I will explain how social networks analysis works in real life using WhatsApp and Instagram. First, let's look at a WhatsApp. In a WhatsApp group, each person's like a node, and the message between them are the connections. Some people message many members. These people have high degree centrality. They are important because if they share something, it's spreaded very fast inside the group. There are also some people who are part of circles. They have high betweenness centrality and they help information move from one group to another. Now let's compare this with Instagram. Instagram works with a direct network where A can follow B, but B may not follow A. So if many people follow you, you have a high in degree. These are usually influencers or popular accounts. Instagram uses this followers network to recommended accounts and post based on SNA algorithms. So the platform understands what type of content you like by studying the structure of your network. And next, real-time SNA, so SNA in schools and office. Social network analysis is very useful in real-time situations like schools and offices. In school, we can study how disease spread. Students are notes and their contact with the others forms the edges. Some students meet many others. These are super spreaders. They have high degree centrality. Similarly, students who connected to different groups act as bridges and help the disease spread faster using SNA. School can identify this key students and target them for quick testing. Vaccination or starting changes. This help control outbreaks more effectively. In office, SNA helps us understand communication patterns. Employees who send emails to many teams or the central communications hubs. People who connected to departments have high betweenness and they help information follow by studying these networks. Companies can identify bottlenecks, improve teamwork, and retain their communication structure. So overall, SNA helps organizations make better decisions and message informations, teamwork, and public health more efficiency. Thank you.
Good morning, everyone. Today, I will dive into social networking analysis, a PowerPoint technique used to study the relation and connection within a system, being with people, organization, or even data points. We will look at a SNE does not examine some of the critical real-world applications. Like first, we have to identify the players and bridges in the static networks. Simply, undirected graph highlights influence and connectivity roles. We will first look at the bridges. Bridges. They act as a bridge connecting distinct points in the network. Because first we have to understand the core concepts like network and nodes. SNS is about understanding a network. A network consists of node. It's nothing but edge, vertices. These are the individual entities in the network. For example, a people, a computer, a country, or a company. And also, edges like these are the connections or relations between the nodes. For example, friendship, communications, and trade, disease transmission, etc. SNS use graph theory to qualify a visualize these relationships and then identifying the key roles in the networks. Before looking at the applications, it is crucial to understand how SNA identifies the most important components in the static graph networks. A player. First of all, we have to look at the player. A new player in a node that highly connected and centered, often referred to as a hub. For example, node B act as a hub, holding pieces together, and SNA matrices. These roles are often quantified using centrality measurements like degree centrality. This is nothing but how many connections in a node has, or betweenness centrality, which is nothing but how often a node lies on the shortest path between two other nodes. Now the second part is bridges. The bridge is nothing but a node or a tile that concepts connected otherwise distinct separate parts of the network. It facilitates to overflow the information resources and between groups. For example, node D act as a bridge connecting discrete parts and in the network. Significantly, removing a bridge can fracture the network, while knowing the other bridges, the virtual of effective spread and control of information. Now let us see the practical applications of the SNA. Application. Practical application uses cases across industries to optimize strategy and detection. In this, first of all, we look at the marketing. Marketing use case. They identify the top influencers for targeted promotions. How it is nothing but how SNA helps in this analysis of networking of following an interaction. SNA identifies individual with high influence like hubs who can effectively spread a message. This is a fair most effectively just looking at follower counts. And cybersecurity detects suspicious or anonymous network connections, like how SNS helps in it detects unusual patterns like the employee communication frequency with the external server that can usually don't or a group of computers suddenly forming a new tight can cluster. Connections can be signal frauded, security branches, or malware activities. After that, we look at the healthcare, track diseases and information spreads among patients. Yeah, in this case, by mapping patients' contacts and movements, public health officials can be model and predict how quickly a disease can spread over it and identify the initial hub or bridges is crucially for assignments. And in the education system, we can analysis student teamwork and social dynamics. How SNA helps in this one means it can map collaborative tiers for identifying isolated students groups that work well together or students who act as a key knowledge of distributors like bridges. This information helps teachers optimize group assessment and identify students needing social supports. Finally, we can implement and strategy. In this case, optimize statistical, enhance detection, improve coordination, personalizing experiments. How SNS helps in here means it is a broad sense. SNE provides the data drive basics for implying overall strategy, whether it optimizing supply chain routines, like finding the most effective connections, proving teamwork, not proving, it is improving team coordination by identifying the communication or personalizing a user contact field. SNA helps organizing management and leverage their relationship effectively. By this, I can conclude that social network analysis is a essential, which is multiple discipline tools by qualifying the connections between entities. It also allows us to identify key players, location, critical bridges, and the unlimitedly gain a deeper understanding to how a influence information and resource flow through a system. This insight drives more effective strategies in everything from targeted marketing and to diseases containment. Thank you. Thank
Hello friends, let us see the conclusions of the experiment. Conclusion is the power of SNA with static graphs. First, static graphs help us see hidden structures in social, digital and organizational vectors using a single snapshot. They also help us identify influencers, communities and the communication patterns. They drive how influencer follows. Static SNA gives a baseline understanding. This is useful before studying dynamic changes or predicting trends. One limitation is that static graphs do not show changes over time, but they still reveal how nodes are connected. So even with the limitation, static SNA is very useful for starting deeper analysis and planning interventions. Let us see the next example for the movie recommendation via user interface G graphs. Let us test UIG. Um, Users other nodes and their interaction likes, views or watch histories become the edges in the graph. When user shows similar views, habitats clustering occurs, meaning them are grouped together based on taste. This clusters allows the system to provide personalized recommendation to each other. This method is widely used for streaming platforms to increase engagement and user satisfaction. Finally, the system uses networking similarities to predict what each user might like a suggestion approximate content. Thank you.